Introduction to Optimization, Questions for Screen Recording Task, Part 2, Convex Sets and Functions. Question 6. Show that function with positive semi-definite Hessian is convex. The gradient inequality. Let f be a continuously differentiable function defined on the convex set C. Then f is convex if and only if fx plus the gradient of fx transpose multiplied by y minus x less or equal fy for every vectors x and y in the convex set C. Gradient inequality proof. Let f be a convex function. So by the convex inequality, we know that f of 1 minus lambda x plus lambda y less or equal 1 minus lambda fx plus lambda fy. When opening those parentheses and moving fx to the other side of the inequality, we get that f of 1 minus lambda x plus lambda y minus fx is less or equal lambda of fy minus lambda fx. Now we will divide by lambda and get that f of 1 minus lambda x plus lambda y minus fx divided by lambda is less or equal fy minus fx. We will open those parentheses and rearrange the vectors in the following form and get that f of x plus lambda of y minus x minus fx divided by lambda is less or equal fy minus fx. We'll take the limit when lambda is going to 0, and we will mark epsilon to be lambda multiplied by y minus x. So our limit will now look like this. When lambda going to epsilon to 0, epsilon is also going to 0. So now f of x plus epsilon, this is going to be epsilon, minus fx divided by epsilon divided by y minus x. Because here we can move y minus x to the other side of the expression and we get this one. Now we will rearrange this expression in this form. So we get the limit of epsilon going to 0 of the expression f of x plus epsilon minus fx divided by epsilon multiplied by y minus x. And this is equal to the derivative of f in the point x, because this limit is the derivative of f in x, multiplied by y minus x. So we got that the derivative of x multiplied by y minus x is less or equal to fy minus fx. When we move fx to the other side, we get that fx plus the derivative of fx multiplied by y minus x is less or equal fy. And then we prove the gradient inequality. Now the solution for our problem. We can write fy by its quadratic approximation. So fy equals to fx plus gradient of fx transpose multiplied by y minus x plus half multiplied by y minus x transpose multiplied by the Hessian of fx multiplied by y minus x. This is the second approximation of fy. And we also know that the Hessian of fx is positive semi-definite. So by the definition of positive semi-definite matrix, we know for every vector and also for the vector y minus x, it holds y minus x transpose multiplied by the Hessian multiplied by y minus x greater or equal 0. It also holds if we are multiplying it by half. So we got that this fy equals to this expression, but this expression is non-negative. So we know that fy is greater or equal the other arguments of this expression. So we got that fy greater or equal fx plus the gradient of fx transpose multiplied by the vector y minus x. And so we got the gradient equality always holds for a function f that has a positive semi-definite Hessian. Therefore, f is convex. This is the gradient inequality that we proved earlier.